Alrighty, I got a couple more examples where we're using chords. This time we're using the chords and a radius, and we're going to be finding some missing segment lengths. Okay, so we're going to try to use the things that we learned in our notes to help us. All right. So the first thing that we're going to do is we're going to talk about what we know about this chord right here, and whenever it has this guy, which is like a chunk, like a little piece of the radius coming through it at a 90-degree angle. When that happens, our chord gets cut in half into two equal pieces. So in all these problems, I can start just like that. So if this piece up here is x, then that means this piece down here is the same length, x. And what you should see is a very beautiful, a gorgeous right triangle. Cool, so we have our right triangle right there, and we knew from our notes that we were going to be dealing with Pythagorean theorem. So yup, we got some Pythagorean theorem going on here. A little a squared plus b squared equals c squared action. So remember that a squared, or the a and the b are your legs, and the c is the hypotenuse, and the hypotenuse is always across from the right angle, so that 13 is your c, and these guys can be a and b. All right, so that's how we're going to work all these problems. We're going to use Pythagorean theorem. All right, so that is going to be an x squared plus 6.9 squared equals 13 squared. And I've got my handy dandy calculator with me, so I know that 6.9 squared is 47.61, and I know I need to subtract those, that 47.61, so we can get the x by itself, and x squared equals 169 minus 47.61 is 121.39. And then how do I undo a square? I use a square root, and the square root of that is 11.02. So the length of x is 11.02. So that means this distance is 11.02. That means this distance is 11.02. That means this whole chord here would have a distance of 11.02 plus 11.02. So the whole chord would be like 22.04. They didn't ask for that, but I'm just saying we could figure it out because we're smart. Next example. So another very similar example. We're going to use the same idea that I know that these two pieces of the chord are congruent to each other. So if this guy's 9.9, then guess what? This guy's 9.9. I could have done that. Or I could have said, hey, this radius is x. So if I redraw the radius somewhere else, it's going to still be the same length. So you could have done it either way. You could have redrawn the radius or moved that piece of the chord to the other side. Either way, it's a right triangle. So we're going to be using Pythagorean theorem again. Remember, the C is the side that's across from the right angle. So in this case, the X is our hypotenuse. So the A can be 6.2, the B can be 9.9, and the C has to be X. So let's go to my handy dandy calculator, and 6.2 squared is 38.44, and then 9.9 squared is 98.01. Add them together, 38.44. And that's 136.45. And remember, to undo the square, we use the square root. And x equals the square root of that. Oh no, push the wrong button on my calculator. 136.45 square rooted, and I get 11.68. So our hypotenuse is 11.68. No matter where I draw it, it's going to be 11.68. If I wanted to redraw it over here just for fun, it's still going to be 11.68 no matter where I draw the radius. The radius is 11.68 units of whatever. All right. This one's just a tad bit different. We got a little missing piece over here hanging off the edge there. Now, I'm going to solve this up just like I did before. I'm going to talk about the fact that if this chunk is 13, then this chunk is 13, and I've got a right triangle here. I'm going to worry about that x later. I'm going to come back to you later. Okay, so for right now, I'm gonna call this this missing piece of our triangle. Let's just call that I don't know. Let's call it y for right now. Okay, because x is already used, so let's call it y. So I see my right triangle right here, and I see that the hypotenuse is 17, so the c is 17. So my a squared plus b squared equals c squared. And for a, I'll put 13 squared. And for b, I don't know, I'll use y squared. And then the c has to be 17 squared. So that's going to be 169 plus y squared equals 17 squared, which is 289. I've got to subtract. And y squared equals 120, and I undo the square using a square root. So y equals the square root of 120, which is about 10.95. So check this out. So I'm going to focus on this piece right here. This y part was 10.95. I'm going to erase some of this stuff so we can really look at it. So this y part here was 10.95. All right. And then I'm trying to find this x part. This whole segment has a name. It goes from the center to a point on the circle. So that whole segment is the radius. All right. So I know that my radius is 10.95. And that little chunk x, so my radius here was 10.95 plus that little piece. And now I already know what my radius is supposed to be. I had it right here at the beginning of the problem. The radius is supposed to be 17. So I know that 17 is the length of the radius. So I can use that to figure out what x is supposed to be. So my radius, which is 17, is made up of a 10.95 chunk and an x chunk. So let's do a little subtraction to figure out what that little x chunk is supposed to be. 17 minus 10.95 leaves me with 6.05 for my x. So I'm just going to do this problem like all the other ones, but at the end I'm going to have to do a little figuring out, a little subtraction to figure out what that missing piece was supposed to be. So there's just one little extra step to that problem. Let's do one more kind of similar to it. This one's similar, but it has another twist. Instead of giving us the radius, it gives us the diameter. So if the diameter is 32.6, then the radius is going to be half of that. So we're going to do 32.6 divided by 2. So our radius, which is half of the diameter, because remember, a radius only goes from the center to a point on the circle. So our radius is going to be half of 32.6, which is 16.3. All right. All right, so I got 16.3. I have this side down here, and I don't know this side of the triangle. I'm just going to call it y for right now. So I'm going to use Pythagorean theorem to solve that. I know that the side across from the right angle has to be my hypotenuse, C. So I can do a squared plus, oops, my bad, a squared plus b squared equals c squared. All right, I'll need my handy dandy calculator here. 13.2 squared, what are you? So we've got y squared equals 174.24, and I got 16.3 squared is 265.69. I don't know, I keep putting a equals there, I mean a plus. All right, so let's subtract and figure out what y squared is supposed to be. I got 91.45, and I can get rid of the square by square rooting, and y equals about 9.56. So this little chunk is 9.56. Well, we already know that the whole radius here, this whole radius is 16.3. So if the whole thing is 16.3 and that chunk is 9.56 and the other chunk is x, we can do a little subtracting. To find that x is going to be 16.3 minus 9.56 is 6.74. So that little chunk there is 6.74. Alrighty guys, I know that was a whole lot of math and a whole lot of calculator usage, but we're doing Pythagorean theorem. So, and we're using some of the properties that we learned about a tangent line, and rewind, properties we learned about chords and radii. So there you go. Good luck on your assignment. See ya.